talking about the unit circle a little bit, and today we're going to actually say what is the unit circle, and then tomorrow, hopefully you'll see why people like the unit circle better. Today you might think I'm just a crazy woman for saying that. But the idea is the unit circle is if you took a circle and you graphed it on the xy plane and it had a radius of 1, do you agree at 0 degrees or 0 radians, if it had a radius of 1, the ordered pair there would be 1, 0. Agree with me on that? Any clue what I'm saying? Yes? That would be 1, 0. And if I went all the way up here on the y-axis and it had a radius of 1, that would be the ordered pair 0, 1. And then at pi, have you over here, that would be the ordered pair -1, 0, right? X first. And I don't have this one labeled here, but we could go down here and label down here, and what would that ordered pair be? 0, -1, because I'm just talking about a radius of 1. All of those would be a radius. Yes? We could do that for any angle. There's an ordered pair that goes for any angle. What we're going to focus on in the unit circle are those special angles, pi 6, pi 4ths, pi 3rds. And I'm going to give you the ordered pair. Instead of drawing a triangle, you just learn the circle, and then you know these values. Because for any point out here, I could draw in a line, and then you could do the ordered pair, and you would know what you need to know from that. But what's cool about this is if you think about this as a radius of 1, we can write sine, cosine, and tangent of all of these angles using our same ratios, but now the radius is always 1. So what's the ratio for sine in terms of x and y and r? Y over r. But what is r in a unit circle? So do you agree that if we're talking about a unit circle, sine will always just be the y coordinate? So if you know the ordered pair, you know the sine, because the sine is always the y coordinate. And cosine is normally x over r, but if r is 1, then the cosine is just x. So what's kind of cool about the unit circle is if you know your ordered pair, you know x. If you know x and y, you know cosine and sine, because they're just the x and the y. The question that people have is, well, how do you know if you're in the unit circle? Here's what's kind of cool about it. No matter what angle they give you, you can use it on the unit circle if it's a special angle. So if they ask you to find the sine, cosine, tangent of any angle that we could draw a special triangle for, you can just use the unit circle values. And so the only time you wouldn't use the unit circle would be if they gave you something that, like if they said, the sine of theta is 7 over 12, that's not the unit circle because the hypotenuse is obviously not 1. You with me on that idea? That was a question that people had yesterday. But if they just ask you for an angle, then you can use these values. Tangent is still y over x, but you can still use the ordered pair there. Like it's still the same thing. And I like to give you all 6 of these, but I hope by this time, if you know sine, cosine, and tangent, you know for the reciprocals, you just flip them over. So if sine is just y, then cosecant is just 1 over y. And if cosine is just x, then secant is 1 over x. And if tangent is y over x, then cotangent is x over y. And be aware that these could be undefined. If x is 0, tangent's undefined. If y is 0, it's undefined. I'm not going to write that again, but like you could write next to this, like where y cannot equal 0, where x cannot equal 0. But it's kind of implied that we know we can get undefined values here. So the question is, what is the unit circle? I'd like to use it, but how do I use it? So the big idea today is I want to just show you where these values come from and how we can use them, and that's really all we're going to get to today. And then tomorrow I'm going to show you a little trick of how maybe you can memorize the unit circle, because it's a bit overwhelming at first when you see it. I'm supposed to memorize that, but hopefully I can teach you some good tricks. So I broke it up into 2 sections at first so you can see where it comes from. This is 2 pi broken up into 8 equal parts. So what does each one of these measurements represent? You know? 2 pi all the way around, it's always tricky with the 2 pi. So these are our 45-degree increments. So if you want to label this, this would be 0, this would be pi fourths. Hopefully you know now this is pi halves. This is 3 pi fourths. This is pi. This is 5 pi fourths. This is 6 pi fourths, or 3 pi halves. And 7 pi fourths. A third on the outside and one on the inside. What I'm going to give you is the XY ordered pair that goes with each one. And if you know your triangles, you're going to kind of see where this comes from. But I'm just going to give you, if I plotted the point here of how far on the X and how far on the Y would I be if the radius was 1, the ratio here is going to be the square root of 2 over 2, comma, the square root of 2 over 2. That would be the ordered pair. What's kind of nice about the unit circle is if you know that is the ordered pair for pi fourths, if I come over here to 3 pi fourths, do you agree that the X and the Y are going to be the same numbers, only the signs are going to change because I'm over in quadrant 2 now? Just like with our reference triangle. So I feel like reference triangles and unit circles are very closely related, but it just depends on which one you pick to do. So if I'm over here at 3 pi fourths and I want to find that same ordered pair, it's still the same distance on the X and the same distance on the Y, but in quadrant 2, the X is negative. So I'm going to say that's negative square root of 2 over 2, but the Y is still positive. And so that's where the reference triangles kind of bleed over into the unit circle. Because are all of these points going to kind of be set up with the same triangle if we were drawing a triangle in? Which means all of them are the same distance, it's just changing the signs. So in quadrant 3, it's still going to be these two numbers, but in quadrant 3, X and Y are negative. So that's negative square root of 2 over 2, negative square root of 2 over 2. And in quadrant 4, same distance away, only in quadrant 4, X is positive, so positive square root of 2 over 2, and then the Y is negative. And eventually, hopefully, we'll get to a problem in a minute, and you'll see how we can use this. So that's our 45, 45, 90 triangle, kind of put on the unit circle. This is broken up into 12 equal parts. So if you took 12 divided by 2 pi, 2 pi divided by 12, you would get each one of these are in increments of pi 6 or 30 degrees. So this would be pi 6, this would be pi thirds, it's still pi halves, this would be 2 pi thirds, this would be 5 pi 6. And honestly, I don't know if you caught on to this yet or not. The more you draw the unit circle, I hope the more that you see this. For me, I always think about my sixths are right next to the x-axis. Like this is pi 6, this is 5 pi 6, the one after it is 7 pi 6. The one over here is 1 before 12 pi. Sorry, 2 pi would be 11 pi 6. So I always remember the ones right next to the x-axis are my sixths. And then the other ones are my thirds. So the one right next to the y-axis is pi thirds. The one on the other side of the y-axis is 2 pi thirds. So that makes this one 1 1/3 or 4 pi thirds. So that makes this one 5 pi thirds. And for those 3 pi halves, pi, 0. Again, just ways that kind of help you think about when you're labeling that. Or you can always count by sixths. If you know that it's 12 equal parts, you could just count 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, and reduce it as you go. But you got to be able to know those angles. And again, I'm just going to give you the ordered pair that goes with it. And all you have to know to do a unit circle problem is know this ordered pair. And I know today it's kind of overwhelming, but it'll get better. But for this one, the ordered pair is square root of 3 over 2 and 1/2. If we graph the point of that, what the ratio or the xy point would be, if the radius was 1, would be square root of 3 over 2 and 1/2. And then this one is going to be 1/2 square root of 3 over 2. And it should make sense to you that 30 degrees and 60 degrees, they just switch, because when you draw a 30 degree, 60 degree triangle, the sine and cosine just switch places. And again, if you know that, we should know everything else. If this is pi 6, could you tell me what the point for 5 pi 6 is going to be? Yeah, exactly the same ordered pair. You just say I'm over here in quadrant 2 now. So now it's negative square root of 3 over 2, 1/2. And do I know what 7 pi 6 is going to be? Yeah, it's the same ordered pair because it's the same distance away. It's just in quadrant 3. So now this one would be negative square root of 3 over 2, negative 1/2. And 11 pi 6 would be square root of 3 over 2, negative 1/2. And again, I still use the idea of reference triangles because I think about all of these are the same distance from the x-axis. So that's why they all have the same point. You just change the signs. And could I do the same thing with pi thirds? 2 pi thirds, 4 pi thirds, 5 pi thirds. It's going to be the same ordered pair. You just change the signs based on what quadrant you're in. So you get negative 1/2 square root of 3 over 2. You get negative 1/2 negative square root of 3 over 2. And you get 1/2 negative square root of 3 over 2. And the reason I wrote this out separately is because like putting it all together at first is a little crazy. But if you squish that together, that is your entire unit circle. And there's one in your book. I think it's in like the front cover or the back cover. There's one in section 4.3 even. And we'll write it out better tomorrow. But it's in section 4.3. Okay. So this, we're not going to write this out today because we're short on time. If we had a full period, we would write it out. But just know they've just taken that 45 increments and put them in here. So like the smallest one, this is pi 6, and then pi fourths is squished in the middle, and this is pi thirds. So that's 30 degrees, 45 degrees, 60 degrees, and it's just increments all the way around. So we could take those and write them in, and we'll do that tomorrow when I show you my little shortcut. You could do that tonight if you want, but I just wanted to be aware that that's what they talk about when they talk about the unit circle. If you know your 30, 60, 90, and your 45, 45, 90 triangles, and your reference triangles, you don't have to know this, but I think after tomorrow you might like this better. So, what can we do now? Let's look at these. Oh my goodness, we're doing so great. I'm so good at teaching in these 25 minutes. I don't know what I'm going to do with 48 minutes. Or I could just teach a lot to make up for all this lost time. I just evaluate the 3 trig functions just to show you what to do here, but obviously if you could find sine, cosine, and tangent, you could do the other ones. But if it says using the unit circle, all you have to do is, if you know the unit circle, is give me the ordered pair. Because if you know the ordered pair, that's all you need for this. So pi thirds, let's go back here. Pi thirds is right here. All you need to find your trig functions now is that ordered pair, which is why if you're going to use a unit circle, you've got to be able to reproduce this. So for pi thirds, not 4 pi thirds, but for the angle pi thirds, I know that the ordered pair is 1/2 square root of 3 over 2. Yes? So to find the sine of pi thirds, it's just the y coordinate, which means I don't have to draw a picture. I just have to know that. And the sine is the y. What's the y? Radical 3 over 2. And the cosine of pi thirds is the x. And what's the x? 1/2. I just found sine cosine. And the tangent of pi thirds, a little bit more work. This is why I like my triangles, because I can do stuff without a crazy fraction here. Tangent is y over x. So that would be radical 3 over 2 over 1/2. Yeah, we're never going to leave a fraction in a fraction, ever. So remember that when you divide by a fraction, it's the same as multiplying that up by its reciprocal. So divided by 1/2 is the same as multiplying by 2/1. So the 2's cancel, and I get the square root of 3. Yeah? Not on board yet, I can tell, but that's okay. We might have enough time here. I might show you the trick today to make you. I showed the trick the second hour today because they're a day ahead of you. And they said, why didn't you show us this yesterday? So let's see if I can squeeze it in. What's really great about the unit circle is for those weird angles like 0, pi halves, pi, and 3 pi halves, it's weird to do it with a triangle. We did that yesterday where I drew like 0, negative y, and we had to think about it. For the unit circle, what is the ordered pair at pi? Pi's over here. -1, 0. If you know that, finding the sine, cosine, and tangent using x and y, really easy now. You don't have to think about y and r being y and all that weird stuff. You can just say, what is the sine of pi? And sine is y, and y is 0. And what is the cosine of pi? Cosine is x. X is -1. And tangent is y over x. Y over x is just 0. Yes, no, maybe? What if they gave you an angle like number 3? -pi6 is not on the circle that we just made. Can we still use the unit circle to find the sine, cosine, tangent of -pi6? Because what is -pi6? Or where is -pi6? Or what can we do? What do we do? Anybody? People shaking their head. What do you do? Negative angles, you go the opposite way, right? So you have two ways of thinking about this. If you want to think about it in terms of the unit circle, if I just go down -pi6 is an up +pi6, could you tell me the ordered pair that goes with that value there? I mean, you can look at the picture. I don't expect they haven't memorized yet. But this negative goes the opposite way. How can we make a negative angle positive? Like, how could I make a different angle, a coterminal angle to -pi6? Yeah, if you don't want to think about graphing a negative, you could just add 2 pi to this, and you would end up right there at 11pi6. Either way, you got to know that's the point that you're at, and then you should be able to tell me that that is radical 3 over 2 -1/2, I think. I'm not a unit circle fan, but once I teach it, like, it just comes back to me, and then I got it again. And if you know that point, could you do sine, cosine, and tangent again? Yes, even if it was bigger than 2 pi, you could go around the circle, or you could subtract 2 pi and get those values. Any multiple of 45 degrees, 30 degrees, or 60 degrees, you could find the sine, cosine, and tangent of. Yes? I want to show you the trick to maybe brighten your day a little bit. So let's go back to this. If you were going to make this, it kind of seems overwhelming. Like, how in the world am I going to make this on my test? Step 1, do you agree that finding these points aren't that bad? Like, this would be 1, 0, because it's a radius of 1. This would be 0, 1, -1, 0, 0, -1. Like, those you just have to kind of know or think about. And then here's the thing. If you could know quadrant 1 using your reference angles, could you put them all where they go? Do you agree with that? Like, you really only have to memorize quadrant 1, and then you just fill them in where they go. Because pi6 is going to go with all the other 6, and pi4 is going to go with all the other pi4s. So here's my trick. Make your ordered pairs. And we're just going to count. We're going to start at the top and count 1, 2, 3. And then we're going to stay at the bottom and go back up and count 1, 2, 3. 1, 2, 3, 1, 2, 3. And then we're going to put everything over 2. So 1, 2, 3 down, 1, 2, 3 up. Put everything over 2, and then all you got to do to make the first quadrant is take the square root of all the top numbers. What's the square root of 1? Square root of 3, square root of 2, square root of 2, square root of 3. We just did the first quadrant without having to think about what goes where. 1, 2, 3, 1, 2, 3, all over 2, square root the top. I seem unimpressed. Then you just flip them over. Like, I don't really know that we need to write them all down, but you should see all of the ones that are the same distance away from the x-axis as pi 6 are going to have this exact same ordered pair. We just change the signs. So some people, when they get a test in my class for pre-calculus, the first thing they do is they write this entire circle. I think that's a bit silly, but if you want to do it, you can. I say if you know the first quadrant, then you can just fill it in as you need it. You might not need the whole circle, but it's really easy to do now. We should have like a time test, like who can make a unit circle the fastest? Negative square root of 3 over 2, 1/2. Down here is just going to be negative square root of 3 over 2, negative 1/2. And over here is going to be square root of 3 over 2, negative 1/2. Yes? Pi force is my favorite, and it's going to become your favorite because you don't have to remember which one's which. It's just square root of 2 over 2, square root of 2 over 2, and you just change the signs. And pi force are all the ones in the middle. So this is just going to be negative square root of 2 over 2, square root of 2 over 2. This one's going to be negative square root of 2 over 2, negative square root of 2 over 2. And this one's going to be square root of 2 over 2, negative square root of 2 over 2. And then the only one left are all the thirds. Pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds. And again, they're all the same distance away. Like, they're all up here 60 degrees or pi thirds away from the x-axis. I showed you this. And again, we're just going to take that 1/2 square root of 3 over 2 and change the signs. And that is the unit circle. So that's why people like the unit circle, because it looks kind of crazy at first. But once you get this, you just flip them all around. Yes, no, maybe? I don't care. They told me in second hour today that for someone that doesn't like the unit circle, I'm trying to sell it awfully, like I'm really trying to sell it to you. I don't care which way you do it. I like triangles, but you just got to pick one way, all right? Or you can kind of do a mixture of both. I tend to do that. What I want you to do today for homework is not all this. This is tomorrow. That's not it either. It's what's in red. On your homework, this is what 4-3 day 3 says. But today, all I want you to do is 29 and 31. And I believe those are using the unit circle. And then 67 through 70. Like, that's all you have to do today. And then tomorrow, we'll work on the green part. So you just need to do the red part for today. And then we'll finish up talking about sine and cosine tomorrow. And hopefully sort of be on track to have a test maybe next Wednesday-ish. Maybe. We have 3 minutes left, kids. This is the most time we've had all week. Like last week. It's the most time we had in like 7 days. So, you know, if you have other homework questions or you just want to look at your homework tonight, it's a great thing to do.